Hi everyone, and welcome to our next episode of our Roundup Meetup series. And if you're new here, this event is hosted by the blockchain professionals community, and we are kind of a think space of blockchain engineers, of blockchain professionals who are interested in the concept of blockchain and who are also interested in its early adoption. And we have such meetups every Tuesday. And please subscribe to our social media channels to keep yourself updated about our future events and get all the invitations and to find the recordings of our previous sessions. And we also have many other activities, such as conferences. For example, our next event will be dedicated to multi-party computation wallets, and our next big event is the Blockchain Professionals Conference, which is going to happen on June 6th, and that will be a 4-day online global conference. Please visit our social media pages once again and check out our website. And I am your host, Alec, and today we are going to talk about account abstraction together with our friend Andrei Sherbovich, who will be giving a presentation. And at the end, we will go to our live chat. Just a second, let me invite. Hi, Andrei. How are you?
Yes, hi Alec. Thanks for having me here. I'm good, thank you.
Yes, thank you for coming. So Andrei is ex-mobile developer and product owner at Safe. And without taking any of your time, I will bring your presentation to the stage and you are good to go. Good luck, Andrei.
Yeah, thank you, Alec. So, hi everyone who's here together with me. Okay, and I will talk a bit about the account abstraction. So, as many of you maybe already heard, it's quite hot topic latest years and this year especially. So, let me probably start. I'll start with a bit introduction about myself. I know that in this community there are a lot of people from EPAM. So, and I'm pleased because I started personally my career in EPAM through a QA engineer course when I was a student in Russian State University. And then I was employed by EPAM in 2006. Then I tried different career paths, starting with QA, then test automation, project management, own startups, backend engineer, mobile engineer, product owner, yeah, in general, broad experience in IT. And in crypto space, I appeared in 2018 when I was first employed by the Gnosis. And since that, I was working on the Gnosis Safe, and now it's known as just Safe after a spin-off from Gnosis last year. So it's a multi-signature wallet, and I work there as a mobile engineer and lately as a product owner. So yeah, this is what you need to know about me today, and I love crypto and things associated with the crypto, so I'm really pleased to tell you more on account abstraction today. Good, let's start. Before we go to the account abstraction, I just want to go through some very basics because I'm not sure about the level of all people here, but it's good to recap that in general in Ethereum there are two types of accounts. There are externally owned accounts. We will call them in the future EOAs. And EOAs are controlled by private keys. So basically, whenever you use Ethereum, most likely you're using MetaMask or any other wallets, and your private keys are stored there. So the way you interact with Ethereum most often is through externally owned accounts. But not many people know, but there are also contract accounts. And contract accounts, they are a smart contract deployed in Ethereum chain. And these accounts are controlled not by a private key, but they are controlled by code. So to the right, there is a nice visualization that I took from some website where you can see that both accounts, like externally owned account and contract accounts, they can have balance, they can have nonce, but the contract-based accounts, they also have associated storage with them that externally owned account don't have, and they have the code. Not the storage, the code, I meant. So wait a second. Yep. Right now, everyone who is using MetaMask or other like with externally owned accounts, we know that like most often you need to write down some seed phrase, which is 12 words. But even the evolution to the seed phrase, it was not instant. And the way we use blockchains right now, it's based on some standards. So even the externally owned accounts nowadays, they had an evolution through several standards, like mentioned here, BIP32, BIP39, and BIP44. Why is it called BIP? Because it's a Bitcoin improvement proposal. So as you all probably know, the first blockchain that was introduced to this world was Bitcoin. And then the way to evaluate, to develop further any blockchain or any protocols, usually is adopted by community from for improvement proposals. And for the private keys, there was also several proposals that came to the state that we know the private keys right now. So whenever we use the MetaMask, which I also prepared here because we will have some demos today, we usually, when we start creating an account, we MetaMask generates for us 12-word seed phrase. But not many people know or understand or generally want to remember that in general, this one seed phrase can control an unlimited amount of private keys, which I wanted to demonstrate. So there is a nice generation tool. And for example, if you generate any 12-word seed phrase, what is happening under the hood that it goes through several standards. And this mnemonic phrase, which is 12 words in our example, it goes to a BIP39 standard seed. Then there are derivation path standard, which was mentioned here, BIP44, right? And the derivation path, it's a way to build, let's say, an unlimited amount of private keys from one seed phrase. And the difference from many blockchains, and especially Ethereum from Bitcoin and others, is exactly in this, how you build this derivation path. So that's why in hardware wallets or in many other wallets, when you have only one seed phrase, like 12 words, very often you can have different addresses depending on the blockchain where you use. And for Ethereum, for example, this 12-word seed phrase, it will, I'll copy it here. It can have many public keys, many addresses, and many private keys. This is not Ethereum, by the way. It's selected another network. It's Bitcoin. Let me select Ethereum. Here. So yeah, just to demonstrate that this is the truth. This is derivation path for Ethereum. Yeah, I copied these 12 words, and I want to import this key in my MetaMask. So, and later today during the presentation, I put some fonts there, and we'll try also to create some safe, just for demonstration purpose. So I will say that I forgot my password, and I want to re-import my seed phrase into my MetaMask. MetaMask is most popular web browser-based wallet in the Ethereum space. So I paste here the seed phrase, do some password, restore my account. And as you can see here, in my account details, here's my public key, public address, 2632. So you can see the same in this tool, 2633. So this is the first address generated by the seed phrase. As I mentioned here on the web slide, it's important to remember that with one private key, with one seed phrase, you can control unlimited amount of the private keys. And here I will also generate the second address. In MetaMask, every time you add a new address, here, Sorry, my browser is not responsive today. Maybe because I demonstrate my screen, I'm not sure. Yeah. In MetaMask, if I add or create another account, let's call it account 2. Under the hood, it does exactly the same. So following all these BIP standards, it just generates a new public-private key. So this private key for this public key, but actually everything is controlled just by one seed phrase. So the second address that I generated should be 78.6D. Let's just double check that this is correct. Yeah, 78.86D. And the way how many people are using, for example, right now wallets, so they import or store one seed phrase, then generate many addresses, then they can have different accounts associated just with this seed phrase. But this is the way how EUAs or externally owned accounts work right now. And now we will move to like what disadvantages currently we have with this flow is that in general, first of all, this is full self-custody, and with great power comes the great responsibility. But in general, like for the wide adoption, we as a humanity or like human beings, we are in general are bad at managing secrets. Yeah. So there are different researches that show, for example, that 58% of users admit forgetting their passwords frequently. And in general, in Ethereum space or in blockchain space, it's well known that people who are not very aware about the cruciality of storing the seed phrases or passwords securely, they often lose funds. This is because we, in general, get used to the custodial world when like different companies with their convenient infrastructure help us storing the secrets or recover access to our accounts. But to adopt the large amount of people to understand the full power of the self-custody, it also will require some good investment in the self-education. And it will be hard for many people to overrule this rule, don't make me think, and to get rid of the dominating patterns of the Web2 world in the new Web3 space. But also with the evolution of Ethereum, as we see like much more Web3 products appearing, people are storing more and more tokens. Now we also acquire a lot of reputation. There are pop-ups, we visit events, we generate nice names. So a lot of more value started associated with different accounts. And most of these accounts are controlled by EUAs. So this is a short preamble to the moment when we come to the account abstraction idea. So as remember in the first slide, in EVM chains, there are two accounts, EUAs and contract accounts. And account abstraction idea is to somehow eliminate existing of two types of accounts by unifying them. And ideally that there is only one type of account in Ethereum, which is closer to the currently contract accounts. At this stage, at this moment of the time, contract accounts, it's important to mention, they don't have private keys. So whenever you generate a contract account, it has balance, it has storage, but it doesn't have any private keys, right? To unify them, it would be possible to achieve in several ways. First way is to make some change in the protocol itself in the Ethereum and make a hard fork when you force all the miners adopt the standard, all the players to accept the new reality. And then you need to think about, okay, the majority of current users, they use just MetaMask or EUAs account. How could you also migrate them to the new type of accounts so that it continues working smoothly? And now we have this account abstraction idea. Another idea of evolution to how to make the account abstraction or smart accounts as a majority is through simple evolution. So when new type of accounts or smart contract accounts, they becoming much more popular than EUAs. And with the time, the share of EUA accounts, it goes much below the share of smart contract accounts. And with some standards adoption, it's naturally brings to the minority, and maybe later will be eliminated completely. So, but again, whenever you hear account abstraction, everyone is talking about account abstraction. Usually, people want to abstract this private key logic, which is basically UA's legacy, from the account address itself. So whenever that you will have your account address, where is your reputation, your treasury lives, whatsoever lives, but the security model for this account, it can be flexible, and there are zillion ways of manage or establish these security models. So smart wallets or smart accounts, they exist even nowadays, and they appeared like at the different experiments with different approaches how to organize them, even before this account abstraction topic got the broad attention. And I was working for the Safe, Gnosis Safe, which was one of the first experiments of building smart wallets, but there are also many other companies were experimenting. But smart wallets, they are different from classical MetaMask or EOAs. Yeah. So first of all, smart wallets, they cannot initiate transactions on their own, because the way how Ethereum works is that only EOA accounts can initiate transaction in Ethereum network. Because for initiating transaction, you need to sign it, and to sign it, you need a private key, and only EOA accounts, they have a private key. So this is one of the first biggest disadvantages. Then only EOA, for example, in many use cases, when you interact with the Web3 world, you need to sign some message or some approval or something. And again, to sign something, you need a private key, and only externally owned accounts they can sign with the simple logic of a private key. But on the other hand, smart wallet developers, they were thinking, okay, how can we also introduce the signing logic without the private key? And there are kind of ways to do it. So there is a standard ERC-1271, how to verify signatures for the smart wallets in general. And it works, the standard is there, but the problem is that still not many dApps support this standard. And something that is not enforced like by the protocol itself, but something like leaves just a standard. And what is standard? Standard is just a recommendation. It has a problem of adoption. So that's why smart wallets, they're still suffering. The user experience of smart wallets, it suffers compared to the EOA's user experience, because not so many dApps, they support some standards that are crucial for smart wallets, for example. But smart wallets, they also have some cool advantages, yeah? So if I think that if you have account with some treasury or some assets there, and you want to authorize, make a transaction from this account, in ways it's simple. Your private key and signature of the private key is authorization. In smart wallets, you can authorize making transactions from this account with an arbitrary smart contract logic. We will go through like a bit later what does it mean, but it gives you much more flexibility of how you can authorize. And also smart wallets gives some advantages like transaction batching and some other use cases that I will demonstrate in live later when we will go through Gnosis Safe. Okay, when I say that smart wallets can allow arbitrary smart contract logic for authorization, what it actually means, it means that you can build like many other use cases, whatever can come to your mind. So for the smart wallets or smart accounts, you can build use cases for multi-signature smart wallets. And this is what Gnosis Safe is about. So multi-signature should not be confused with multi-party computation, MPC's wallet. And I know that the next session probably will be about MPC's wallet here. But multi-signature wallet is where you need to provide several signatures with different private keys, or not only private keys, just to generate one final signature, which will be validated on the smart contract before allowing executing any transaction. Also, this authorization means that you can configure flexible recoverability options. Like you can experiment with ideas like social recoverability. When, I don't know, some circle of your friends can recover access to your accounts, or dead man switch. So trying to tackle the ideas, okay, how to enable treasury transferability in case like someone dies, for example. You can also program like custom logics like white or blacklisted operations. You can say, okay, from my account, I want this super secure treasury storage of my lifetime savings. And from this super secure storage, I want to allow only to withdraw to these three addresses, maybe this address of my wife, of my kids, or whatsoever. So you can encode this logic in your account that it would be possible to withdraw their funds only to these whitelisted addresses, or to allow only some whitelisted operations. You can allow some daily limits, or imagine many different use cases. Again, some of them I will demonstrate a bit later today. Cool. Safe, the product that I was working for like more than 4 years while I was part of the Safe team, is an example of account abstraction, where you abstract your address from the private keys themselves. And you can be really flexible about the managing security scheme of your one account. So we will now do some Safe demo. And here the demo time. Hopefully we'll have enough time. So today we created 2 accounts with a MetaMask using our test mnemonic. Here it is here. I have account, come on. I have account 1, account 2. It has empty balances, and I will be using for my demo Gnosis chain. It's EVM chain, so it's completely compatible with Ethereum, and all the account abstraction ideas we can validate there, but it's just cheap transactions, and I will send here 10 cents to make the demo and experiment. So first I will just top up this account with 10 cents. Give me a sec. Hopefully no one will try to empty my account because you all see the seed phrase. Yeah, but if there will be problems, I will recreate a new account. So I just made a transaction. And here I have my 10 cents, right? So now we will go to the Gnosis Safe website and we'll try to create our abstracted from the private key account. So we'll go to Save Global. And we'll do some short demo right now. And I also will demonstrate some advantages of smart contract accounts compared to EUAs. And we'll go through them in short. So here I will just create a new safe. How can I MetaMask? Next. So as Gnosis Safe is multi-signature wallet, I can create as many owners of this account as I want. For example, I can figure into myself, and I just want to have a safe with a 2-factor authentication, or where to produce any signature, I need to, or where to produce any transaction, I need to verify this transaction with 2 signatures at least. So here I will just add 2 owners. Both of the owners will be controlled by the same seed phrase, but technically it's different private keys. Yes, so this account 1 is pre-populated here, and I also take the account 2. I will copy it here, and I'll enter it here. So, and I will say that I need 2 out of 2 owners to verify the transaction before it will be executed. We can continue. You see the transaction cost is like fraction of a cent. That's why we're using Gnosis chain here. Now what I did, I just submitted a transaction that was initiated with my why? Because I initiated with no, right? Okay, sorry, I'll repeat it one more time. What was created? I think it was created. So we can validate it because I sent this transaction from UA of MetaMask. I'll just go to transaction details. So it was here, view on Block Explorer. And we can see the transaction was successful, and indeed it created a safe. Okay, that's good. So what we can see here is that now I created my safe, which is another like a smart wallet or basically smart account. It has its address and it has associated code with this. And the code that it has associated is like a simple multi-signature oriented code that just checks necessary amount of the signatures allowed executing transactions and stuff like this. So right now I don't have any funds in this wallet and I can send here some fraction of cent. So I'll just copy the address and then I'll just go to settings, appearance, copy address, and I'll send some small amount of funds to my safe. So I'm gonna send anyway, and I'll just increase the fonts. So in case if it's hard to see. I'm really sorry that it works so slow because when I was testing on my laptop, it was working much faster. But maybe because I demonstrate the screen, we just need to wait these small delays. Okay. So I had to top up this account with some small amount of XDAI so we can make actual operations with funds from the safe and I can demonstrate how it works with a small amount, okay? So once this transaction is done, you can see that it has now 0.003 XDAI, which is like, yeah, XDAI is equivalent to US dollars, so this is less than 1 cent. And what we can do with it, let's go and swap XDAI to some other currency, just to demonstrate how it works. We'll go to the side of the sushi. And you can see our balance. And let's swap 0.001 to USDT. Almost one-to-one exchange rate. We swap it. And to make a swap, we should initiate transaction. So one of the cool things on the Gnosis Safe is that it has the simulate feature. So before initiating every transaction, you can simulate it and to see the simulation outcome using Tenderly. So it will demonstrate how the balances change, to do some additional verifications. Usually when you are like Gnosis Safe users, very often it's companies or it's people with a lot of funds stored there. So in making any transaction can be insecure. So I always recommend doing some simulations, double checking every transaction that you want to make. When you're sure in the result, you can submit it. And when we submit the transaction, we initiate, first of all, the first signature. Yeah, so I will just sign it. So that transaction was submitted. When the transaction is submitted, it's not yet how to say, sent to the blockchain. It appears in the queue because we have only one signature produced. Yeah, as we remember, this is a multi-signature wallet, and I need 2 confirmations for every transaction to be sent. So here in the queue, transaction queue, we can see that I want to interact with my account with this contract. This is some method that I want to send there, so I can double check that I'm doing some exchange. Whoever is familiar with the smart contracts, they can also go to the contract source to validate that this is from the valid, that this is a valid contract, not some scam. But basically, when you're sure that everything is okay, you just approve the second signature. So I'll go here and sign it with my second account. Come on. Okay, so this is my second account. I submit the signature. Well, now, once I have all the signatures collected with my smart account, and you see that I detached my account, which is this one, from single private key. Right now in my scheme, I have several private keys. I collected all the required signatures, and I can send this transaction to the blockchain. It will be executed, and will do all the logic. As well as I can replace all these private keys in the future. So if I, for example, lose access to one of my private keys, or it get compromised, or it gets stolen, with additional security measures, I can easily replace them, remove them, or whatever I can do. In this way, we abstract away the fact that, like, for all your lifetime savings, reputation, or storage, you need to be hardly binded to a single seed phrase or a single private key, which might be much less secure than trying to manage your security schemes in a better way. But this is not everything that smart accounts allows. So I now have this transaction in the queue, and you see it's ready and executed, and I can execute at any time. Let's make another transaction when I want to send some funds to my second account because it's completely empty right now. So I have this account with empty XDAI, and I want to send some funds. Let's do this one. Now in the queue, you can see that I have 2 transactions. Yeah, one transaction which is like swap, and another transaction which is send. And the second transaction still miss one signature, so I'll just produce it right now. Cool. Now I have two valid transactions which I signed, and they both valid. And one thing, for example, that you can do with account abstraction or with smart wallets in general that you cannot do with the EOAs is transaction batching. I want to demonstrate how it looks like. Transaction batching allows me, for example, I produce two independent transactions, with two independent services. And why I want to batch them to execute in one single batch, meaning in actually one EVM transaction. So I'll just do execute batch. And you see how it looks like. It shows that this is the first action, this is the second action. I can simulate the full batching to see what will happen. You can play around like on your own later. But now I just want to send this batch with the two transactions to the EVM chain, which is Gnose chain in our case, and see what will happen. So just send this batch. And it's done. So under the hood, we can see that I performed two transactions in a single batch. And to see if I have USDT in my account, that the exchange was actually done. Yes, now you can see that I have USDT swapped on XDAI. Cool. So I already demonstrated some advanced features with what is possible with smart contracts, and in general, what additional advantages can account abstraction bring if it will be more widely adopted than EOAs. So what we demonstrated, we created an account that is detached from a single private key. Yeah. So, and the security, how you can manage for this account, will it be at all attached to any private key is like up to you. We demonstrated the transaction batching, something which is possible only with the smart wallets. We have not touched the modules yet and didn't talk about the upgradability, but we will talk about it a bit later today. So another cool thing which is possible with account abstraction or with the safe, that for example, with the safe, we demonstrated that we have 2 out of 2 keys, but in general, keys are not necessary should be EOAs. Key can be also other smart accounts. Remember, we mentioned this EAP 1271 here. So ERC 1271 is the way to validate that the signature produced by smart wallet is a valid signature. So why do we need a key? Keys generate signature. What if this key is not EOA, but any other smart wallet, like the safe itself? If there is a way to validate that the signature produced by another safe is valid signature, then it can be a key to another safe. So what it means, like you can build really complicated or interesting schemes where one safe is an owner of another safe. Why it can be interesting, for example, in the corporate world, or when you build like DAO treasury. And DAO is a big organization that manages, for example, billions or hundreds of millions. And you want to say, okay, in this DAO, we want to collect signatures from other organizations. And one of the key can be another DAO organization. Another key can be just a private key of some DAO owner, and etc. Yes, so you can build the whole departments where you can collect signatures from different sub-organizations. So in this way, you detach the validation logic, the way how you produce the signatures, from the private key, from the EOAs, but it can be much more complex stuff. Besides the much more interesting in various validation logics, you can also add a lot of programmability to your smart accounts, for example, Safe. With the permissions, transaction checks, possible to recover the account if something bad happens, some automation, and many other stuff. Again, all this possible because contract-based account, they have associated code. Whatever you can bring to the code, it can be, you can extend the use case of the account. So in externally owned accounts, there is no associated code, only simple operations. For example, one of the interesting concepts that is possible to build on top of Safe is like example of full decentralization or keyless DAO treasury. Like as many of you know, DAOs, decentralized autonomous organizations, they usually have treasuries. As I said, they can manage like millions or hundreds of millions in USDT equivalent. And usually the treasury, the treasury, DAO treasuries, they live on top of the Safe contracts because of its flexibility and programmability. But what if this Safe contract of the treasury, they will not have any owner at all? How it could look like, yeah? So imagine that this DAO, they have some governance process, and they create a proposal that they need to spend some treasury on some purpose, I don't know, to fund some, to help with some disaster or to do anything else. And this proposal is created for the DAO token holders. And then when it's voted, for example, yes, this transaction should be executed automatically based on the outcome of the proposal voting, yeah, of this governance system. So with the Safe, it's completely possible to organize. And the way how it might work is that in Web3 world, some oracle can monitor the outcome of the proposal, and based on the outcome of the proposal, it can trigger some transaction via module, and this module can execute the transaction without validating any collected signatures of the treasury. And here we come to the concepts of the modules. Concept of the modules in the Safe is it's like a root access or a backdoor. I don't know how to call it. I will go here with the modules, right? So in the basic flow of the Safe, there is a logic of validating signatures of owners. And if there is enough signatures, you can execute the transaction. But a module is like a root access or a backdoor, which is when it's connected, it also have associated logic with it. And module can perform a transaction skipping the basic flow, skipping the validation flow of the like signatures, right? So how it can be useful? One of the examples, for example, is a daily limit module. You can say, okay, I can enable some module with a very simple logic. I say that I can, for example, for this specific address, I can send $100 once a month without collecting signature of all owners of this treasury. And anyone can initiate this transaction once a month because it's whitelisted address. This can be done with the module. Another way to adopt the module power, as demonstrated here, when this module has a custom logic that is, for example, binded with some decentralized oracle. This decentralized oracle can monitor some outcome of the governance system. And if governance system decides on using treasury somehow, it can automatically execute the transaction without the Safe owners. Right now, like many DAOs using this concept, but usually they have some veto power or some mechanics to stop because this is still a young area. It has a lot of experiments and there are different attacks on DAOs whatsoever. But in general, with account abstraction, it's possible to build like full decentralization or keyless DAO treasury, which is cool. I also want to, like we have a bit more time, I want to demonstrate how you can use the module right now in Safe with the daily limit module, just to demonstrate the power of the modules. As you see right now, there are no modules. connected here. But in Gnosis interface, you have the native support of the spending limit module. So when you add it, we say that beneficiary address, for example, one of my owners. I take account 1. And to this beneficiary, I can send xDai, or I can send up to 1 tether every day, for example, right? So you do the simple configuration. Based on this configuration, some code module with some parameters will be attached to the save. I submit this. Ooh. Yeah, the user experience with Web3 World is still like need to be way more improved, because now I need to jump between different interfaces, switching accounts, doing a lot of stuff, but yeah. So I submit and execute the transaction at once, plus 9. It's not gonna die. See? It's just not execution. And I will execute it. So with this transaction, we actually adding a module to the safe, and like once it is done, we will see it in the interface. So here you can see that this module was connected. It belongs to the safe modules list. So every safe or smart account, it has a list of modules which is enabled for this account. And how it works, for example, in this interface, when you make some funds transfer, in this case, I will select an asset tether. And the recipient to the first account, as far as I remember. Yep. And you see here we have an option to select it as not a simple multi-signature transaction, but a spending limit transaction, where I still have limit of 1 USDT for today. So whenever I proceed, I can submit it. And in this case, as you can see, I don't need to collect the second signature or whatsoever. So I added basically a custom logic that skips the signature validation. Yeah, so it goes for this backdoor or module or whatsoever. So this is in general how the modules work. And this is why it's possible to build a lot of custom logics. Yeah, how you can make treasuries for the transaction. And this is basically the way or why why you can experiment with some ideas like semi-custodial solution, limited treasury management, daily limits I was mentioned, advanced recoverability options, social recoverability, deadman switching, etc. On top of safe, it can be done, for example, just with the power of modules. Every module can be a separate smart contract with a specific logic encoded there, integrated with different external systems. So basically, you can build a lot of interesting use cases just using this simple pattern. Cool. We were here, and now I want to continue with the programmable account and account abstraction. So, oops. What I demonstrated today with the safe and with the modules and in general, the narrative of the safe is a programmable account. But the narrative as account of abstraction is merging two types of account of Ethereum in one, or abstracting away the account address from the private key itself, right? So as I said, programmability is an ability to introduce new logic to an account, but abstracted account or abstracted account abstraction is not necessary should come with the programmability. There are some products in the space, for example, Linen Wallet or Argent, that experiment with the account abstraction without the like necessity to reuse this programmability. This because programmability is something needed for advanced users, for maybe their organizations, or when you need to build some use cases. But if you want to bring some simple smart wallet to masses, people experiment with some limited setups or some limited use cases, which are using account abstraction but not using programmability. For example, I have two examples here. One is Linen Wallet, which is built on top of safe contracts, and it always using the 204 keys. So when you're using Linen mobile app, one key never leaves the phone. You cannot export it from the phone. It's just encoded in the software itself. One key is controlled by the Linen team on the backend. And when you initiate a transaction on your phone, the backend, for example, it can do some fraud protection, detection, some additional logic checks. So to prevent the not so experienced users from losing accidentally funds or from signing something bad or maybe doing some transaction. But this is still a self-custody wallet because only with the one key on the backend, they like the Linen team still cannot do anything with your funds because you have 204 key. You still need to authorize it from your phone. But if you lose your phone, you can still recover your account because they have another option of recovery phrase, which is 12 words that you should store somewhere securely. And these 12 words will control two keys that we demonstrated before, that in MetaMask one seed phrase can control unlimited amount of keys. So whenever you lose, for example, your phone, you can use this recovery phrase to recover access to your account. So simple scheme, probably might be more interesting for less advanced users and also bringing a bit more security than just the OA wallets. Another example is Argent. So Argent has a narrative of seedless accounts. So basically they want to bring the wallets to the masses, saying, oh, seed phrases is very complicated. We don't want users to think about it at all. To manage them, what they need to do is to set up some circle of their friends or the people to whom they trust. And these friends or parties, they will be their guardians. So again, there are some protection about what you can do with your funds, but the full custody is achieved. That still Argent team, it doesn't control your account completely, but your close circle of friends, they can recover access to your wallet if you lose it or if something bad happens. And Argent, for example, they develop their own infrastructure and own set of contracts, and they are built not on top of the safe. So as I said, account abstraction concept, it can be built in a different ways, using different logics and different smart contracts. Account abstraction evolution. So I recommend, hopefully this presentation will be shared later. I recommend to read the article from the road to account abstraction from Vitalik. So there he shortly recaps how the path was till the moment where we are right now. And right now, the community effort is focused around EAP 4337. So it's a standard. It's not a change of the protocol of the Ethereum itself. it's more or less a standard. And what is a standard? It's like a set of smart contracts or interfaces where smart wallets they should conform to. And around the standard, around these interfaces, companies try to build some infrastructure that will allow to use the standard across many different dApps. But the idea of the standard is that, again, the verification or the signing logic is detached from the private keys. So there is a check-in logic, there is a payment logic, there is some way how full nodes or miners they should install special software, or full node providers like Go Ethereum or Ethermind, they should introduce additional logic that will allow to monitor transaction from a separate mempool, not from EOA's mempool, but from the separate mempool, and operations that, or user operation, which is basically a transaction, they can be broadcasted to this separate mempool. They can be bundled together and they can be added to the single transaction with the transaction batching functionality. And then this single transaction with many user operations from different accounts, they can be added as a bundle transaction to an Ethereum block. So this is, in short, what was the idea behind 4337 EAP. There is a specification about it. But yeah, it's the concept is to use the shared mempool separate for this standard. Abstracted way necessity to have external owned account to initiate transactions. Transactions can be broadcasted to the mempool, and then there is a way to add them with the infrastructure. But of course, the account should pay the fee for this transaction to the miners who still add them. And the fee can be extracted away also from the Ethereum or from the native token of the chain to some ERC20. Like, for example, you can always pay a fee in USDT or USDC. It's also possible with account abstraction. Separate validation and execution logic, batching and aggregation. It also, this standard improves the way how the rollups can become cheaper on different L2 chains. And again, this standard will not require any protocol changes, but it will take some time, probably not so long time, while like many chains and many miners, they will adopt the standard on their side. Safe right now, it doesn't support this standard, but with the next iteration of the smart contracts, which will appear this year, I believe, Safe v.1.4, it will support the standard. And Gnosis chain, for example, also one of the chains that want to support the standard as soon as possible. So there will be contracts, popular contracts. There will be some more or less popular chains. We're going to build products on top of it and try experiment with account abstraction to bring use cases to the market. And there are a lot of ideas that you can experiment with. So there is a lot of not properly discarded fields like semi-custodial solutions. For example, what if some old infrastructure provider can incorporate some logic to recover access to your funds? So if I live in Germany and I use Deutsche Bank, what if Deutsche Bank, for example, don't have access to my funds, but I say, okay, if something bad happens, like this and this and these accounts, they should have access to my main account or something, some other dedicated logic. So this is why I call it semi-custodial. Or even to try to build some community-owned decentralized banks where like a lot of additional logic or tight binding of DeFi solutions to smart wallet accounts. Yeah, this is also probable way of evolution for current wallets. So stuff like this, there is a lot of opportunities. So anyone who probably might think about doing some innovation in this field, yeah, take your time, do research. It will be plenty of possibilities. Yeah, thank you for being with us. It's just in time. It's 1 hour. You can reach me on Twitter or better in Telegram or write me on email. If anyone of you will be on the ETH Denver that will start in 1 week, I will be happy to meet you there and to talk about crypto account abstraction and in general. Yeah, thanks for watching.
Okay, Andrei, thank you so much for for such a great presentation. And we have a couple of questions in our live chat. And the first question is from Conrad. He asks, are Q transactions awaiting confirmation stored on chain in smart contract?
Now, Q transaction, they are stored in the convenience infrastructure. So it's a backend service that aggregates different signatures. And then, yep, they stored there. They are not stored in chains.
And the second question is, what address is final signing address of ATX from in Etherscan? Is there any way of tracking back from Etherscan TX to actual confirmations, original wallets?
Yes, because there is a way to track who are owners of the safe. If this is the question, yeah. First of all, this is public information. You can just using simple API paste there the safe address and to see who are the current owners. But it also from every transaction possible to extract which owner actually signed it. Of course, it will be visible in the safe interface itself you can use, but it also is possible to do from the Etherscan transaction because yeah, just need some decoding knowledge.
Okay, and before we get any new questions, let me ask a couple of questions from my side. To
Yeah,
be
sure.
honest, I'm not that technically advanced in the all that in the engineering questions. By the way, Conrad says awesome presentation. Thank you. So you
Yeah,
answered the questions. And
thanks.
my first concern is when will account abstraction get here? I mean, when will we have this truly mainstream adoption of it?
I'm really bad maybe at prediction the future. I saw a lot of articles that states, okay, account abstraction is already here. There are smart wallets, they're getting more adoption of the safe grows, adoption of Argent and other smart wallet grows. Everything contributes to account abstraction. And I know that at least in the community of major smart wallet players, there is already an agreement, like with the next iteration of their smart contracts, to adopt this AP 4337. So whenever the next big update cycle happens and like smart wallet providers, they upgrade their contracts, they will try to incorporate 4337 already, and this will allow also to bring more adoption to it, right? So right now, AP 4337 as it is not adopted yet at all, almost. But I believe that in the next couple of years, adoption of it will grow significantly.
Hopefully, yes. And uh, spoiling our next webinar, which will be dedicated to multi-party computation, the question is as following. So does account abstraction somehow compete with MPC?
I think they have different purposes. Yeah. So MPC is the the way to steal decentralized the signatures from a single UA. So as far as I remember how it works, it's like in a private way to split part of the private keys, and that like the input data that you send, it can be signed by different parties, and then the final signature is collected in some anonymous way. But under the hood, it's still UA signature. Yeah, it's just the way how you distribute it between many parties. So still the account that produces the signature, it will not have associated code. It will not have possibilities to bring many more use cases besides like splitting the signature between different parties. So you will not be possible just by using MPCs introduce recoverability, programmability, and other concepts. Yeah, but I think that MPC providers, they can be naturally integrated with smart contracts in a way. Yeah, nothing prevents, for example, having a safe with a one key, and this key is an MPC key. So this is another way to abstract signatures or just some experiments. That's why you can experiment with whatever you want, what users will like, I don't know.
Okay, I think somehow clear for now. And let's see what will happen. And I think that was the last question. If we will get some after after we publish the recording on our YouTube channel. I will let you know, Andrei. And thank you so much for such a great presentation about the future of the wallets and for answering all that questions. And it was really a pleasure to have you with us. And before we go, I would like to remind that, as I told before, our next presentation will be next Tuesday, same time, which will be dedicated to multi-party computation. And please scan the QR code on the screen to visit our registration page and get the links and all the invitations. And I think now we are ready to conclude our today's webinar. And thank you all for coming, for attending, and we hope you have learned and enjoyed this presentation too. And wish you good luck.
Yeah.
Thanks, everyone. Thanks, Andrei. Bye bye.
Thanks one more time for having me. Bye bye.